All right, here we are on the 3.5 practice set, which is number 16. And I'm just going to go ahead and do the problems for you here. And, you should be trying these on your own, but if you get stuck, you're more than welcome to look at this, right? So we're trying to use implicit differentiation. Remember, implicit means that our x's and y's are all mixed together. We're trying to find dy dx, which another word for dy dx is y prime. So I will be interchanging between those two notations as we go. Okay, so what we're trying to do is we're trying to take the derivative with respect to x of this function here. So we just go through and say, okay, let's take the derivative of this first piece. Please notice that it is a product, right? There's two things being multiplied, which means I need to use product rule, right? There's my u, here's my v. So u prime is going to be 2x times v is just the y, plus v prime is going to be the derivative of y, right? The derivative of y with respect to x is, we're going to write this one as dy dx, the derivative of y with respect to x, times u x squared. Okay, that's the first piece. And then notice that the other one also, the next term over here, also has a product going on. So we have to use product rule again, right? You got to get really good at product rule and stay good at it. So now derivative of x is 1 times y squared plus derivative of y squared is 2y dy dx times x. And this is all equal to derivative of 6 is 0. Okay, now our job is to get all the dy dx's by themselves on one side of the equation and everything else on the other side. So we're going to, the ones we're saving for this side are this one, and everything else, meaning this one and this one, are going to move to the other side, right? So if I move them to the other side, they become negative, right? So what we're going to end up with is an equal sign, negative 2xy, right? I just moved this 2xy over there, becomes negative, minus 1y squared. I just moved that other one over there, it becomes negative. And then on the left-hand side, what's left is x squared dy dx, that's this guy, plus 2xy dy dx. Right, the terms with the dy dx are there, and the other ones are on the other side. Right, so let's now factor out a dy dx. That's why we got them all on the same side, dy dx. Our right hand side is not going to change for this. Right, if I factor out a dy dx, what's left? Well, this x squared is left, and there's a 2xy that's left. Right, and the reason we do this is now I can divide everything, both sides, everything, by x squared plus 2xy. And that will give us dy dx equals negative 2xy minus y squared over x squared plus 2xy. And I have successfully found dy dx, right? That's what it asked if it said find dy dx. There's dy dx, it's this guy. Alright, so that was that one. Going on to the next one, same idea. Our goal here is to take the derivative of this function with respect to x. So let's just start. Derivative of x is 1 plus derivative of tangent is secant squared. You need to memorize that. Secant squared, the inside stays the same times the derivative of the inside. So I have to take the derivative of the inside, right, and multiply it here. The derivative of x times y, that's a product. You can use product rule to take the derivative of that. So the derivative of x is 1 times y plus the derivative of y is dy dx times x. And that's what we have. And this is equal to 0, right? Derivative of 0 is 0. Now remember, our goal now is to get everything with the dy dx on one side and everything else on the other side. So what we're going to need to do is actually distribute this secant squared in there. Right? So we're going to have 1 plus y secant squared xy plus, let's just x secant squared xy times dy dx. Right? Notice how I'm just keeping that at the end. It's just like the conventional way of writing it, is keeping it at the end. And now we're going to go ahead and move everything that doesn't have dy dx to the other side. So we're going to move this guy and this guy to the other side. Remembering that if I move them over there, they become negative. So it's going to be negative 1 minus y secant squared xy. And on the left-hand side, we just have x secant squared xy times dy dx. And there's no factoring that I need to do because there's only a single term that has dy dx, so I can just divide both sides by this secant x secant squared xy on both sides, the whole thing. And what that will give us is dy dx equals negative 1 minus y secant squared xy over x secant squared xy. And if there was some simplification to do, we would do it, but there's nothing to do in this case, so we're just going to leave it just like that. Right, there's our answer. We found dy dx. Okay, moving forward, it says find the equation of the tangent line and the normal line. You get a little hint over here what the normal line is. So remember, we're basically trying to find y minus y1 equals mx minus x1. Right? That's the equation of a line. I'm already given x1 and y1. All I need is that slope, which is the derivative at 1. So I need to find the derivative, plug in 1, or plug in that point, I guess. So we're finding y prime. We're taking the derivative of a sine, which is cosine. Inside stays the same, but then I have to multiply by the derivative of the inside. Derivative of pi x is x. Derivative of y is, in this notation, let's go ahead and use y prime. All right, just like before, our goal is to get all the y primes, all the dy dx's are the y primes, right? And notice how I'm using a different notation now. We need to get all of them on the same side. So let's distribute this whole thing in to that set of parentheses. And this will give us y prime equals x cosine pi x minus y minus y cosine pi x minus y. This is y prime. Right, y prime, that's this guy. And now we want to get all the y primes on one side, so we're gonna move this over by adding it to both sides. So what that looks like now is going to be y prime plus y prime cosine pi x minus y equals x cosine pi x minus y. We're going to factor out the y prime. So you have y prime times 1 plus cosine pi x minus y equals x cosine pi x minus y. And you divide both sides by this guy to give us, we're going to have to go over here, y prime equals x cosine pi x minus y over 1 plus cosine pi x minus y. It gives us that. And we want to know what's the derivative at the point 1, 0, right? So we're going to plug in 1, 0. So we're plugging in, everywhere I see an x, I plug in a 1. Like that. And everywhere I see a y, I plug in a 0. And what this gives us is the derivative, the slope at 1, 0 is cosine of pi over 1 plus cosine of pi. Turns out cosine of pi is -1. So this gives us -1 over 0, which tells me that, what? That tells me my slope is undefined. Then you got to think to yourself, well, what kind of line has an undefined slope? It's a vertical line. What's the equation of a vertical line? X equals whatever the x coordinate is, right? So the equation of this line is simply x equals 1, because it's passing through 1, right? The slope is undefined, must be vertical, it must pass through x of 1, so the equation is simply x is 1. The y could be whatever you want it to be. Yep, that's kind of a weird one, but that's how that goes. All right, moving on to part B. We also want to write the equation of the normal line, right? So normal lines have opposite reciprocal slope. So remember, our slope was -1 over 0. What's the opposite reciprocal to -1 over 0? Is it not just 0 over -1? So the normal line will be, well, now we'll use our equation, y minus our y coordinate equals, our slope is 0 times x minus our x coordinate. But when you do all that, you're just going to end up with y equals 0. So that's our normal line, is just y equals 0. Right? Again, that was kind of a funky situation, but that's what it had. That's what it turned out to be. All right, let's do B. And we're going to do B over here. So B is y squared 2 minus x equals x cubed. We want to find the derivative because we want to find the slope. Instead of using, we could do this either way. All right, let's just do it this way. So this is a product, y squared times 2 minus x. We're going to use product rule. So derivative of the first one is 2y, y prime, times the second one, which is 2 minus x, plus the derivative of the second one, which is -1 times the first, which is y squared, equals x to the third. Sorry, equals derivative of the right hand side as well, which is 3x squared. Then we want all the y primes on one side. There's only one y prime on this side, so everything else just has to move over. So this can be 2y, let's just rearrange 2 minus x, so put the y prime at the end. We're going to move this over to the other side, right? This guy's moving over, so it's going to become 3x squared plus y squared. And then we're going to divide both sides by this, right? So we'll end up with y prime equals 3x squared plus y squared all over 2y, 2 minus x. And we want to know the slope at 1, 1. So y prime evaluated at 1, 1 is going to equal 3 times 1 plus 1 over 2 times 1 times 2 minus 1, which is going to give us 4 over 2, which is 2. So the slope is 2. So my tangent line is y minus 1 equals 2 x minus 1. Right? This is my tan line. My normal line has the opposite reciprocal slope. So it's going to be, the point doesn't change, right? All that changes is the slope. What's the opposite reciprocal of 2? Well, 2 is 2 over 1. So the reciprocal is 1 over 2, and the opposite is negative. And that's your normal line. That's your tangent line. All right? That's how that goes. Let's check our time here. Yeah, we're going to go ahead and stop this one and make another one for the rest of these guys.